Assalamualaikum and greetings. My name is Adamuddin and we are from Group 10. Today we will be presenting our Mechatronics project titled Smart Energy Efficient Lighting Recommendation System. Our group members include Muhammad Hasnul Hadi, Ahmad Daniel, Muhammad Azhar, and Ahmed El Mansur. Without further ado, let us proceed with the presentation of our project.
Assalamualaikum and hi. My name is Ahmad Daniel bin Abdullah and I will present on our project concept as well as the project objective. For our project, we are tackling the inefficiencies of the manual static window blinds. In the real world scenario, people often forget to adjust their blinds, missing out on optimal natural sunlight. Our solution is a smart system that automatically handles this problem. To demonstrate this, we built a simplified prototype using an Arduino as our central brain, an LDR acts as our eyes to check if the sun is shiny or if it is too dark. A PIR motion sensor acts as our occupancy detector to see if someone is actually in the room to benefit from the light. When the logic detects that natural light is needed and someone is present, our Arduino commands a servo motor to mechanically open the window blinds. Our project is driven by two main objectives. The first is to measure the ambient light levels using optical sensor. In our Tinkercad model, we achieve this by using an LDR to constantly rate how much sunlight is hitting the room. And finally, our second objective is to design a logic-based control for energy-efficient lighting decisions. While we often think that the lighting decisions are just simply turning a light bulb on and off, the most energy efficient lighting decision you can make is actually to use natural sunlight instead of electricity. Therefore, our Arduino logic decides when to mechanically open the window blinds via a servo motor, ensuring that the room gets optimal natural sunlight without wasting any power.
Good afternoon, Dr. Saifuddin. My name is Ahmed, and I'm going to talk about the Arduino connections and the coding part of our project. So first, the system is built using Arduino Uno as our main controller, combined with two sensors and two output devices. So the LDR sensor, of course, like it's connected to an analog pin A1 to measure the ambient light level, while the PIR, the motion sensor, is connected to a digital pin D2 to detect whether the person is present in the room or not. So for the outputs, an LED is connected to pin 13 to indicate when lighting is recommended, and servo motor is connected to pin 9 to simulate certain opening and lighting activation. So the breadboard is used to distribute the power from the Arduino's V5 and ground pins, and the LDR is configured as voltage divider to provide accurate analog readings, and the LED is connected with a resistor to limit the current and protect the components. So for the code and decision logic part, so the system logic is implemented in the Arduino code. So the LDR sensor value is continuously reading and compared to a predefined threshold to determine whether the environment is dark or bright. At the same time, the PIR sensor checks for motion and outputs a digital signal. Based on those two inputs, the Arduino applies simple decisions. If the environment is dark and motion is detected, the system turns on the LED and rotates the servo to open position. In all other conditions, meaning if the room is bright or unoccupied, the LED remains off and the servo stays in the closed position. This ensures that the lighting is only recommended when it's actually needed. For our threshold for our project, we put the light threshold equal to 500. So if the motion is higher than 500, it's going to be considered as bright. If less than 500, it's going to be considered as dark. So overall, the system operates continuously in real time. It first reads the ambient light level using the LDR, then takes the motion using the PIR sensor. The Arduino processes both input and determines the appropriate response. The LED provides a clear visual indication of what the lighting is required, while the servo motor simulates a physical action, such as opening curtains. Additionally, the serial monitor is used to display real-time data, including the light level and motion status and system decisions. This helps to verify that the system is functioning correctly during testing. In summary, the system demonstrates a simple but efficient way to improve energy efficiency by ensuring that lighting is only used when the room is both dark and occupied.
Assalamualaikum and hi. I am Hasnul Hadi and I will be showing how the system is implemented in Tinkercad. So this simulation is used to convert our design into a working circuit and to make sure everything operates correctly before we move on to building the actual hardware. It also helps us reduce possible errors during physical implementation. So the circuit is built using an Arduino Uno as the main controller, and as discussed earlier, the LDR and PIR sensor are used as inputs to the system, while the LED and servo motor are used as outputs to represent the system response. For the connections, the LDR is set up in a voltage divider configuration and connected to analog pin A1. This allows the Arduino to read different light levels based on the surrounding environment. The PIR motion sensor is connected to digital pin 2, where it sends a signal when motion is detected. On the output side, the LED is connected to pin 13 and is used to indicate whether lighting is recommended. The servo motor is connected to pin 9 and it is used to simulate opening the curtain. During the simulation, the Arduino continuously reads data from both sensors. It then checks whether the conditions meet the system requirements. If the environment is dark and motion is detected, the LED will turn on and the servo motor will rotate to an active position. If either condition is not met, the system will remain inactive. Overall, this Tinkercad simulation helps us confirm that the circuit and logic are working correctly, and it gives us confidence before we proceed to the actual hardware implementation.
Now I will present the results and discussion of our system. For testing, we recorded the system output from the Arduino serial monitor and compiled it into Excel. The results are shown as follows. When the LDR value is low, the system detects a dark environment. However, if no motion detected, the system keeps the lights off. This shows that the Arduino prioritizes occupancy, meaning energy is not used when no one is presented. When the environment is dark and motion is detected, the system turns the LED on. At the same time, the servo motor rotates to represent the curtain opening. These simulations allowing light or activating the lighting system when needed. This is the only condition where the system uses energy, which confirms correct operation for our project. When the environment is bright and no motion is detected, the system keeps the lights off. This is expected because there is sufficient natural light and no occupant present. Even when motion is detected, if the environment is already bright, the system does not turn on the lights. This shows that the system avoids unnecessary lighting even when someone is present. From the data, we can see that LDR values below around 500 are classified as dark, while values above 500 are considered bright. This threshold allows the system to consistently distinguish between lighting conditions. From a discussion perspective, the system demonstrates effective integration of multiple sensors to improve decision-making. By combining both light intensity and motion detection, the system is able to make more accurate and reliable decisions compared to systems that rely on only one input. The light threshold value used in the code acts as a control parameter to classify the environment as bright or dark. Based on our result, this threshold is suitable for our testing conditions, as the system consistently responds as expected. However, this value may need to be adjusted depending on different environments, since ambient lighting conditions can vary and affect sensor readings. Additionally, the LDR sensor is sensitive to external factors such as shadows or sudden light changes, which may influence system performance. The use of the servo motor also demonstrate how electrical signals can be translated into mechanical motion, representing basic automation in a real system. Overall, this project shows strong potential for application in smart home system, particularly in improving energy efficiency through automated control. Next, I will pass the floor to the final presenter, Azhar Izzuddin.
So, for our conclusion, we have successfully developed a smart energy efficient lighting recommendation system using Arduino. The system integrates two key sensors, an LDR to measure the ambient light intensity and a PIR sensor to detect motion. Now, based on these outputs, the system makes intelligent decisions to control lighting. From our experimental results, we tested multiple scenarios when the environment was dark and motion was detected, with LDR values around 52 to 57. The system correctly turned the lights on and activated the servo to simulate curtain opening. In contrast, when there was no motion in dark conditions, the system kept the lights off to avoid unnecessary energy use. For bright conditions with LDR values above 500, the system consistently kept the lights off regardless of motion, since natural lighting was sufficient. These results confirm that our threshold-based logic is accurate and reliable. Additionally, both our Tinkercad simulation and physical prototype produce consistent outputs validating our design. Overall, this project demonstrates a simple, cost-effective, and scalable solution for improving energy efficiency in smart home systems. Thank you.